Hello everybody, welcome back to another video of the system design playlist. How you guys are doing? I hope you all are doing great. So in this video, we are going to discuss about WebSockets. What are WebSockets actually? How do WebSockets actually work? What is the use case of WebSocket? What is the difference between a WebSocket and a hypertext transfer protocol? What is the difference between a polling and non-long polling? And then we are going to discuss about the challenges and considerations. Why are we actually using WebSocket? So we are going to also discuss about the real case scenario, and then finally the conclusion that we are going to derive from the lecture. So let's get started. Now let's discuss about what are WebSockets actually. We know that we heard this word WebSocket. What is the meaning of WebSocket? So WebSocket are the communication protocol. Remember this word. These are the communication protocol. These are the communication protocol. Okay, so these are used to build real-time features. These are used to build real-time features. How these are used to build real-time features? So we are going to establish a two-way communication between a client and the server. So suppose there is a client. This is actually the client. Okay, so this is a client and there is a server. So hence there is a two-way communication between the client and a server. Okay, it is a two-way communication. Okay, so imagine an online multiplayer game. So you can imagine an online multiplayer game where the leaderboard updates instantly. So for example, we have a multiplayer game. Okay, multiplayer game. Here the leaderboard updates instantly, and as the player scores point, the leaderboard is showing us the real-time ranking of all the players. It shows what it shows. It shows us the real-time ranking points. Okay, so this instantaneous update feels seamless and keeps you engaged. But how does it actually works? We are going to discuss about it. So WebSockets enable a full duplex bidirectional communication between a client. Here is the client. Okay, and here is a server. Bidirectional means in both the direction. So it establishes a bidirectional communication between a client, typically a web server, and a server, not actually a web server, it is actually a web browser. Okay, and then you have a server. So we are going to establish a communication between the client and the server, which is a bidirectional communication. It is done using single transmission control protocol, single TCP connection. Okay, we are going to use a single TCP connection to do that. So unlike the traditional hypertext transfer protocol, where the client send a request through the server and wait for a response, WebSocket worked in a different way. WebSocket allow both the client and the server to send the messages to each other independently and continuously. So after the connection is established, then we are going to use the WebSocket. So I hope you got my point. How do WebSockets actually work? Suppose you have a client and you have a server. Okay, here is the WebSocket which is working in between the client and the server. So the WebSocket connection starts with a standard hypertext transfer protocol request. Who is going to generate that request? Client is going to generate a hypertext transfer protocol request, and the request reaches to the server. Okay, there is a HTTP request here. However, instead of completing the request and closing the connection, the server responds with an HTTP 101. The server actually responds with a HTTP 101 status code. It responds with this status code signifying that the protocol is switching to WebSocket. Okay, this is status code signify this that the protocol is actually switching to the WebSocket. Okay, so after this handshake is done, A WebSocket connection is established successfully, and both the client and server can send messages to each other over the open connection. Now, the handshake is initiated now, it is done, and the connection is established now. Now we can transfer the bidirectional data, and we can do the connection closure after our work is done. So first step, we are going to do the handshaking with the help of the status code. Okay, and then we are going to establish a secure connection. After that, we are going to do the data transfer, and then we are going to do the closure of the connection. Why do we need to do the closure of the connection? Because of security. Okay, so that other device can't hinder the network. So we are going to make our devices secure. That's why we are going to do the secure closure. Let's understand it more deeply. First, we are going to do the handshaking. So the first step is handshake. How it actually works. Okay, so we are going to deep dive into it. The client initiates a connection request using a HTTP GET request. So here the client initiates a connection request, HTTP GET request. Okay. So either the client is using a upgrade header or to set the WebSocket. So here what we are using is we are using an upgrade header to establish a connection using WebSocket. Here we are using the upgrade, and then you have the WebSocket. Okay, and then we are going to establish a secure connection. If the server supports WebSocket and accept the request, it responds to a special 101 status code. 101 status code if the server accept the WebSocket. Okay, indicating that the protocol will be changed to a WebSocket. And like you can see in the output, here we have hypertext transfer protocol 1.1. Here we have the status code, which means like switching protocols. So here we are going to do the upgrade, which is WebSocket, and we are going to switch to WebSocket here. Okay, so here the WebSocket is accepted with some token, and the handshaking is done. So this was all about handshaking. Okay, after the handshaking is done successfully, once we complete the handshaking, the WebSocket connection is established now, which is represented by the status code 101. So this connection remains open until explicitly closed by either the client or the server. This connection will stay open, okay, until it is done for a closure. Then the third step is we are going to do the data transfer. How we are going to achieve the data transfer? So both the client and the server now can send the data and receive the messages in real time. We are going to do the data transfer in real time, means live. Okay, these messages are sent in small packets. So the small packets are also known as small packets. So we also call them as frames. Okay, these messages are sent in the form of small packets. We used to call them frames, and carry minimal overhead compared to traditional HTTP requests, which used to carry all the data at the same time. So we are actually using small packets, which we call as frames. This is done in the data transfer. Remember these points. And the fourth step is we are going to do the closure. So we are actually going to close our connection. Why we are going to do that? The connection can be closed at any time by either the client or the server, as we have already discussed. Typically with a close frame, we are actually going to use a close frame here. Okay, so with the help of close frame, it indicates that the reason is for closure. So the system get to understand that we are going to do the closure of the network, and then we are going to close our connection. So the first step was we have to do the handshaking, and the second step is we have to establish a connection. The connection will stay open until and unless the client, or either a client or server, is going to close it. And then we are going to do the data transfer in real time with the help of small packets, and the small packets are known as frames. Then after that, we are going to do the closure. Closure is done with the help of a close frame. Now further to the lecture, let's discuss why are WebSockets actually used. Why do we need WebSockets? So WebSocket offers several advantages that make them ideal for certain types of applications. So now let's one by one discuss all the applications. The first application is real-time updates. As we have already discussed the real-time updates in the part of data transfer. So the first application is real-time updates. How we can ensure that WebSockets are doing real-time updates? WebSocket enable instant data transmission and make them perfect for applications that require real-time updates, like you have live chat. So for example, we have live chat. Okay, remember these keywords. We do live chatting, and we also do gaming, and during gaming and live streaming as well, we used to communicate with each other. The team players used to communicate with each other in real time. And we have financial trading. We have financial trading, so WebSockets are used over there. As well as we have some kind of live platforms where we use real-time updates, so their WebSockets are of use. Okay, that is the one of the most important application. And WebSockets second application is it is used to reduce latency. Okay, how WebSockets are used to reduce the latency? Since the connection is persistent, there is no need to establish a new connection for each messages. So it significantly reduces the latency. We significantly reduces the latency. Okay, which means we are going to reduce the delay and increase our speed of optimization, or we can say speed of fetching the data. And then the third application is efficient resource usage. It has a efficient resource usage. How we can ensure a efficient resource usage? How WebSocket do that? So WebSockets are more efficient than the traditional polling techniques, as they do not require the client to continuously ask the server for the updates. We do not require to continuously ask for the server for the updates, because we are using packets, small packets and frames, and we are communicating with the help of them. So we do not need to ping each and every time the server, hey, wake up, give me the data. We are actually doing the handshaking first, and then we are going to establish a communication. After doing a communication, we are going to actually do the data transmission, and after the data transmission, we are actually going to do the closure. That is why we are using an efficient resource usage here. And the fourth application is we are going to use bidirectional communication. Here we are using bidirectional communication. So in the WebSocket, we use bidirectional communication, which means that both the client and the server can initiate their communication, allowing for more dynamic and interactive application at the same time. Okay. One of the most important application is it provides lower overhead. What is the meaning of lower overhead? So after the initial handshake is done, WebSocket frames have a small header, as little as it is around 2 bytes. Okay. And it is used to reduce the amount of data transfer. So there is a lower overhead. Now in this slide, we are going to discuss about what are WebSockets, what is the difference between a WebSocket and hypertext transfer protocol, what is polling and long polling. Okay, so let's get started. To understand the advantages of WebSockets, it is helpful to compare them with the other communication methods. So first, let's discuss about the hypertext transfer protocol. You all know about HTTP. It is a request to response model. It is a request to response model. Okay. So in HTTP, the client sends a request and the server responds, closing the connection afterward. This model is the stateless and not suitable for the real-time communication. So remember this keyword, it is not suitable for real-time communication. For real-time communication. Okay. So we are going to actually do two things, like we have a request to response model and we also have latency. We also have to consider latency. Since each interaction requires a new request, here HTTP fails. HTTP is providing us a high latency. Each interaction is requesting for a new request, and a hypertext transfer protocol has higher latency compared to WebSocket. So we are not going to consider hypertext transfer protocol. We need something advanced. Okay, so we are going to optimize our speed. Now let's discuss about polling and long polling. So first, let's discuss about the polling. What is exactly polling? Suppose there is a client and there is a server and we are going to do polling. What is the meaning of polling? So first, the client is going to send a request to the server, and based on that request itself, server is going to create a response. Okay, and then again the client is going to send another request, which is request 2, and the server is going to generate a response 2. Again, the client is going to send a request 3 and server is going to generate a response 3. So here one-to-one is happening, like client is sending a request and it is receiving a response corresponding to that request. Okay, this is how actually long polling, polling works. So here we have repeated request. First point to remember is we have repeated request. Okay, and the second point to remember here is like we have latency as well. It is causing a latency as well. We have high latency. So if we talk about the repeated request, the client repeatedly send a request to the server at fixed interval to check for the updates. While this can simulate real-time updates, so it is inefficient first of all, and as many requests will return to no new data, so we can say that it is inefficient. Okay, the second point is latency. How it is causing high latency? Polling introduces delays because updates are only checked periodically. Okay, so it is causing a high latency. Now let's discuss about long polling. What we do in long polling, we have a client here as well, we have a server here as well. First, the client is going to request to the server, it is going to send a request to the server, and then server is going to wait. It is going to do the pending response or timeout. Okay, and then it is going to generate a response. After that, client is going to do it is going to do the second request. Then server is going to wait. It is going to do the pending response. It is going to check whether there is a timeout or not. If there is no timeout, then it is going to generate a response. So here we have persistent connection. Here we have persistent connection. In long polling, the client sends a request and the server holds the connection open until it has a data to send. Okay, once the data is sent or timeout occurs, the connection closes and the client immediately send a new request. As you can see, the timeout is happening here, and then client can send a new request after the response is generated. Here we have latency. This approach reduces the latency frequency of the request, but still it suffers from high latency compared to WebSockets. Since it requires the client to repeatedly send new HTTP request every time after each request is completed, here we have a high latency compared to WebSockets. We will look into WebSockets. It also has high resource usage. We can say it also has high resource usage. Okay, how we can say that? Because long polling can lead to resource exhaustion on the server, as it must manage many open connections and handle frequent reconnections. So it has high resource usage. Now let's discuss about the WebSockets. What is a WebSocket? How it actually works? So points to remember here is, remember the word bidirectional. WebSocket based on bidirectional communication. Okay, so unlike HTTP polling or long polling, WebSocket allow for two-way communication. See, this is a two-way communication. There is a request and there is a response at the same time. at the same time it is happening. Suppose the time is 1. So at the same time the request is happening, at the same time the response is also happening, and we are doing with the help of handshaking. We are, because the communication or the connection is already open here. Okay, there is a bidirectional messaging here. It has low latency as well. Why there is a low latency? Let's discuss that. So because the communication or the connection remains open, the data can be sent and received with minimal delay. There is a very low delay. Okay, because at the same time we are doing the request, and at the same time we are getting the response. There is a bidirectional communication and the connection is already open, so there is a low delay. Okay, it is more efficient. Obviously, if there is a low delay, it is more efficient, it is more in speed. WebSockets are more efficient in terms of resource usage and especially the bandwidth. So these are more efficient. Coming to the next slide of the lecture. So now let's discuss about the challenges and the consideration. While WebSockets offer numerous benefits, there are some challenges to WebSockets that we have to consider. So the first challenge is proxy server. Proxy server is the first challenge that we have to consider, because some proxy servers don't support WebSocket connections, and certain firewalls may block them. So it is one of the challenge. And the second challenge is scalability concern. Scalability concern. Okay, why do we concern about scalability? Managing a large number of WebSocket connections can be challenging, and considering using load balancers and distributed WebSocket server to handle large scale deployments. Okay, so that is why we concern about this scalability as well. The third challenge is fallback mechanism. Fallback mechanism. So not all the clients or the networks support WebSockets, which can lead to connectivity issues, and implement fallback mechanisms like long polling for clients that cannot establish a WebSocket connection. The fourth point is network reliability. It is one of the challenge. Network reliability. WebSockets rely on a persistent connection which can be disrupted by network issues. Suppose there is a disaster or there is any kind of network issue occurring in between. So implementing reconnection strategies and heartbeat mechanism, regular ping and pong messages can help maintain the connection stability and detect when a connection has been lost. So we are going to maintain with the help of a heartbeat mechanism and reconnection strategy. We are going to overcome that. The fifth point is about security, which is very important. How we can say it is a challenge? Because WebSockets are vulnerable to attacks such as you have cross-site WebSocket attacks, hijacking, you have a denial of service attack, DDoS attack, okay, and you have a distributed denial of service attack as well. So implementing secure WebSocket connections, WSS, authenticate users and validate input to protect against common vulnerabilities. Coming to the next slide, where are WebSockets actually used? So the first point here is we are using the WebSocket many ways, like we are using in real-time collaboration tools. We use in real-time collaboration tools. Okay, so applications like you have, for example, you have Google Docs. You have Google Docs. Okay, so Google Docs may use WebSocket to enable multiple users to edit a document simultaneously, and changes made by one users are instantly reflected for all other users who are doing at the same time, creating a seamless collaborative experience. The second is we can also use them in real-time chat applications. We use them in real-time chat applications. How we are going to use them? One of the most popular uses of WebSocket in the real-time chat application is like you have messaging platforms, like for example Slack. We have a messaging platform like Slack where we use WebSockets to deliver messages instantly. This allows for real-time conversation and immediately delivering the message notification. The third is we also use them in live notifications. We use WebSockets in live notifications. Okay. Social media platforms like use the WebSocket to push real-time notification to the user when they receive a new message, like or a comment. Like you have YouTube. Okay. For example, over YouTube, if somebody comment over your video or somebody like your video, do like, share and subscribe my video. So that is one of the use case of live notification where you get a ping pong message, and you get on the notification bar, you go to the bell and you see the notification that somebody has commented on your video or somebody has liked your video. So instead of the client constantly checking for new notification, the server can push updates to the client as soon as they occur. Okay. So as soon as possible, the server is pushing the live notifications to your dashboard. The fourth application here is we use WebSockets in multiplayer online games. As discussed already, we use them in multiplayer online games. Okay. How we use them? Like in online multiplayer games, low latency is crucial for a seamless gaming experience. And WebSocket provide the necessary real-time communication between the game server and players, ensuring that all the players see the same game state simultaneously. So suppose in the multiplayer game as well, you are doing a live chat or live update, or you are doing some task. Okay, you are doing some task, you are doing some accomplishment. So that should be live. Okay. And there are so many further applications, like we can use them in financial market data feeds. We can also use them IoT, Internet of Things, and we can use them in live streaming and broadcasting as well. Now in this slide, let's discuss about how we can implement WebSockets using the code. So it is a JavaScript code. So let's discuss to demonstrate how WebSockets actually work. And let's look at the simple implementation using a Node.js on the server side and JavaScript on the client side. So this is a code for the server side. This is a code for the server side. And this is the actual code for the client side. Okay. Client side. So what we are going to do, we are going to assign a const and which requires a WebSocket library. So then we are going to initialize a server and a WebSocket which is going to run over port number 8080. Okay. So the socket is going to establish, when the connection is established successfully, we are going to console log the new connection is established successfully. And then we are going to send a message to the client, hello, from the server. Okay. When the connection is successfully established, we are going to send the client a message from the server, hello, the server. Okay. And then we are going to do the receive message from the client. Okay. The server is going to receive a kind of message from the client, any kind of message the client is going to send. And then the message is back again to the client. Though the server is going to send, you said this, so it is going to do the echo. And then the server is going to handle the connection closure. Either the server is going to do that or the client is going to do that. So client is going to do that. Now let's close the connection. So the server is going to receive the request again and it is going to do the connection closure. This is how it actually works on the server side. Now let's discuss how it actually works on the client side. This is how it was working on the server side. Okay. Now let's discuss about the client side. Here we have the socket. The socket is going to run over the local host 8080 number port. So connection is open. Okay. The first step is connection is open after the handshaking is done. So socket add a event listener open, and then we are going to do a console log. We are connected to the server. and we are going to say hello server. Okay, then the client is going to listen for messages. First it is going to check whether the connection is opened or not. If it is open, connection to the server, and then hello server. After that, we are going to check listen for the messages. Then we are going to add event listener for the message. So we are going to do a console log message from the server and the required message which the server has sent. Then we are going to handle the connection closure on the client side with the help of event listener. We are going to perform a close, and then we are going to do a console log, and in the console log we are going to pass a message which means connection is closed successfully. So this is how it actually works in the form of code on server side and the client side. So this was all about this video. I hope you guys like this video. Do like, share and subscribe my YouTube channel Code Muni. We'll see you in the next video. Till then, take care. Bye.